of course, Marconi didn't prevent World War II from happening, so there's still a lot of misunderstandings between people. But I mean, that's one example. I think Fleming discovering penicillin is another example where, you know, that was the first of many drugs which could cure disease and prolong life and things like that. So you know, there were just a lot of things, and in every case, I would say, you know, you can see an advance in science that leads to better life for human beings. On the other hand, you look, for instance, an example is burning coal. I mean, we have to go back a long time now, but we're talking about Watt, for instance, invented the steam. He didn't invent the steam engine. He actually used thermodynamics to perfect the steam engine. And then that allowed people to actually create factories in cities rather than where there was falling water. And that really changed things. And so these are just some examples, but you know, nowadays, I think, if anything, the rate of change of our lives is a lot faster.
So, do you have any specific advice for young Vietnamese students who choose, who wish to pursue physics as their lifelong career?
Well, first of all, it's be prepared for great adventure, because I think it is an adventure, and there's still a lot that we don't understand. So, but I think young people need to, first of all, well, okay, there are two kinds of physicists. There are experimentalists. I'm an experimentalist. I work with my hands. And there are theorists. And, you know, I think people have to realize, first of all, what they're good at. And I've always been good at building things and measuring things and stuff like that. And whereas, you know, mathematically, all this complex stuff, I don't have much patience for that. So for me, I knew right away that I would become an experimentalist. That was pretty clear to me. But I think it's the first, most important thing is that people have to know what they're made of, what they enjoy, what they're good at, and then match that to a career.
What do you think about the importance of self-reliance in scientific research?
Well, it's kind of interesting. I think for science to progress as quickly as it has is largely because of the very, I think, effective communications between scientists. So you know, for instance, I discovered superfluid helium-3, but then I worked with the theorist who then, you know, allowed, you know, us to understand helium-3. And so I don't think that many really effective physicists work all by themselves. They tend to work together. At least that's certainly been my experience.
So teamwork, you say?
Teamwork, yeah. Yeah, but not necessarily a team of, you know, you need people on the team that have complementary skills.
Yeah.
Good.
So you're now a professor at Stanford University. What can you tell us about your teaching experience there?
Well, you know, it's you teach a lot of different kinds of classes. One class that I really enjoy teaching is an advanced lab class. Students, typically in groups of 3 or 4, will choose to do a single experiment in low temperature physics, and then they have to design and build, with my help, of course, the equipment to do that. And so it's like a good experience for them. For a long time, I would teach one term of our engineering entry-level physics class. This counts as a double teaching load, which means that I get out of teaching for one term. But that, you know, you had a lot of students then, and it's kind of fun because some fraction of them will come to my office for office hours. And, you know, that fraction is not very large. The class would be, you know, 300 or something like that, and maybe I would get 30 or something that would come to my office. But you get to know these students, and later, you know, you write letters of recommendation for them for graduate study or something like that. kind of fun. Yeah.
That sounds really great for them. I don't know for you.
Yeah. Well, no. I mean, look. I'm not their parents, but I think of them a little bit as my offspring. It was kind of interesting. Even after I got the Nobel Prize, so every 3 years you have to renew your research grants. And I had a grant with the Department of Energy and one with the National Science Foundation, and I would ask these guys for, every 3 years I would ask for an increment, so I'd get a little bit more money. In the 24 years that I was at Stanford University, well, I still am, but I'm not doing research anymore. Anyway, I never got an extra penny. So after a while, what used to support 2 graduate students would only support 1, and then it was a lot harder to do the research and stuff like that. So, I don't know what to say. It's tough. It's tough even in the United States, but it's got to be tougher for you guys here because you've got less money.
As part of his activities in Vietnam this time, Professor Osheroff met with the leaders of the Ministry of Science and Technology. Let's have a closer look.
As in other countries, young people in Vietnam tend to choose careers with more development opportunities, and that's one reason basic science has become less appealing as a college major. This topic was a major concern raised at the meeting between Professor Osheroff and Deputy Minister of Science and Technology Chu Ngọc Anh. Professor Osheroff's visit may have influenced the current class.
Trong cái cuộc nói chuyện thì rõ ràng giáo sư Douglas Osheroff cũng đã thể hiện cái thiện chí rất là cao của mình. Đặc biệt, xin quý vị các bạn nhớ rằng đây là một cái tên tuổi rất lớn, và đối với tôi là ngành vật lý thì những cái phát hiện từ cái nội dung mà ngài được giải Nobel cùng các cái cộng sự này sẽ mang một cái dấu ấn hết sức tích cực cùng với lại thiện chí của ngài, và chúng tôi tin tưởng chắc chắn rằng dù đây là cái dấu hiệu khởi đầu, đó là cái bước khởi động hết sức tích cực, và giáo sư chắc chắn sẽ là cái cầu nối hết sức là hữu ích trong tương lai với cái cộng đồng khoa học công nghệ Việt Nam.
With its strategy for scientific development, the Vietnamese government set up the National Foundation for Science and Technology Development in 2008 with an annual budget of nearly $10 million. The foundation aims to fund scientific projects by domestic researchers and narrow the gap between Vietnamese and international science.
During the reception held in your honor, leaders of the Vietnamese Ministry of Science and Technology suggested that they would be grateful for your support in the future. Do you have any plans to return to Vietnam?
We'll have to see how that works out. I mean, it's very easy. A lot of things can be done at a distance now. Coming to Vietnam, of course, is a long ways away, and it's a lot of jet lag. But, I never say never. But I think, having some sort of relationship over the internet is so easy now. So we'll see how that evolves with time.
So in a developing country like Vietnam, how do you think we should invest in science, including physics?
Oh, well, you're asking me, I mean, first of all, I don't know how much money you guys have to invest, and so it's a little bit hard to say, but there are 2 issues. One is training young people, and so obviously I don't know what the basis is right now in terms of how many professors you have and what their expertise is and stuff like that. But certainly people, I would guess you have a pretty well-trained set of professors at universities, and what you're probably thin on, I would guess, is equipment and that sort of thing. And like I said, most of the equipment that I used in the discovery that won a Nobel Prize, I built with my own 2 hands. So, but I'm not going to say that everyone's going to do that. Okay, so that's a little bit tricky. But certainly. There are a lot of universities that have old equipment, and certainly we've shipped old equipment off, typically to places in South America, because that's, you know. So I know that certainly is a possibility. I don't know whether for American Physical Society, does it have any programs for what you do with used equipment? I don't know the answer to that right now.
But what do you think are the strategies or approaches that Vietnam should consider for the future?
Oh, okay. First of all, I think no one's going to be interested in doing something if they haven't been exposed to it, is my guess. And so as undergraduates, I think it's good for students to get involved. In the United States now, certainly the opportunities exist, not for every student, but for a lot of students to work in a research group. I think that there are opportunities, and it's kind of really great, I think, for undergraduates to get involved in research, because first of all, you find out what kind of research that excites your passion. And you have to be careful when I say passion, I'm referring to passion for science. and you find out what you're good at, and you also learn some skills, and so that's an important thing. And obviously not, I mean, I don't know how many, we have vastly more undergraduates at Stanford, I guess, than we can have working on research programs. But not all students choose to do that.
So far, how have you helped developing countries like Vietnam in their scientific research?
Well, I go to a lot of different places, and I try to give them good advice if I can, and I try to stimulate young people. Now, I'm not going to give them lots of money because I don't have it. Okay, but you know, I think hopefully that when I leave a country, that people have at least some idea of where they're going to get the equipment to allow them to do the science that they would like to do.
Yeah. And many researchers, after years of studying and working abroad, do not want to return to their home for work. What's your advice in this case?
That's a tough one, because first of all, I think that your researchers will be better trained if they can come and work in an existing laboratory. You know, if they're doing a really good job, they probably have opportunities of staying in the United States or whatever, Europe, or, so that they may not want to come back. Some will, though. They love the country that they grew up in, and of course it helps. They're not going to be too interested in coming back if they think the probability of them doing any more science is nil. So you have to somehow find the money to provide some research support. I'm not so much talking about supporting postdocs or things like that, but building up a laboratory, that's an expensive business.
For this special edition of Talk Vietnam, some of our audience members, who are students, sent us a few questions for you.
Oh my
Would you
God,
like to
okay.
hear them?
Okay, do I have to answer them? Okay, let's see.
So let's start with Nguyễn Thanh Phong, 23 years old, from the Diplomatic Academy of Vietnam. He asked, is it difficult to study physics, and how did you approach your studies?
Okay, well, I just, because of, I guess, all the stuff I did when I was very young, it was kind of quite natural for me to study physics. And of course, I was in a research lab that had 3 professors in it, so I always getting good advice. And there were, I don't know, probably 8 or 10 graduate students, and so we learn from each other and stuff like that. So you know, I think that's the best way for students to learn from each other more than from professors.
So his next question is, what is your next important project?
Oh God, I have no idea what my next important project. My research career is over now, and unfortunately my lab is there and it still has lots of good equipment, but I don't have the time because of all the other things I do now to go in there and pretend like I'm a graduate student anymore.
So another audience member, Lê Phương Thảo, 21 years old, from Hanoi National University, asked, if you had to describe your discovery of the superfluidity of helium-3 in a way that even a primary student who has yet to learn physics at school could understand, what would you say?
I would say, I give up. No. I mean, it is, I think students have to understand something about the BCS theory. But basically, what happens is there are two kinds of particles in nature. Well, there's more than two, but two varieties. There are particles with odd half-integral spin, like 1/2, 3/2. And there are those particles that have even spin, 0, 1 unit of angular momentum. And those particles behave very differently. The ones that have odd half-integral spin, 1/2, 3/2, those are, we call those Fermi particles, Fermi-Dirac particles. And they are antisocial, so they don't like each other. So you can't get two Fermi particles in the same quantum state. Whereas the other particles, I don't know if this may be going beyond. I see
primary school.
Yeah. So the other particles are Bose particles, which have an integral multiple of h bar angular momentum, and those particles are the ones that love each other. So helium-4 atoms, which have an integral spin, form a superfluid at a temperature of about 2.17 Kelvin. I'm not sure the number is exactly right, but around 2 Kelvin. Whereas helium-3 atoms, which are Fermi particles, they're the antisocial ones, don't form a superfluid until you get down to a temperature of order 1 to 2 thousandths of a degree. So it's a very complicated, very different sort of a process that leads to that kind of ordering. What was your question?
I don't think that would help our primary students.
Oh, no. Okay, well.
But I'm sure all the physics students would understand.
Okay.
So in Vietnam, youngsters tend to choose jobs as their parents wish, with preference often given to business-related careers. They seem to not realize that science is also a good path with value. What do you think about the tendency for parents to encourage business? If you were asked to give Vietnamese parents some advice, what would it be?
I think that if you love your children, you should want them to have careers which are satisfying and rewarding. And if they're not interested in going into business, I think you shouldn't force them to do that. It's easy for me to say that.
You had great support from your parents.
I did.
Yeah. So, next question. Can you please give some advice to help Vietnamese children develop their scientific inclinations from a young age?
There's lots of books on physics theory, that's some starting at a very rather simple level. And so I think, you know, students that are willing to read, that's a first thing, okay, to provide them with books. And then I think, you know, if they have questions, it's important that there be someone there that can answer those questions, because they will have questions. But that's one side of it. But the other side is, if you want to go into experimental science, then you need a whole different set of skills. And I guess I started out, you know, when I was very young, you know, working with my hands and learning how to do things, and soldering irons and making transistor radios and all of that stuff. And even in the United States now, people won't do that anymore. So students don't actually learn those skills very, very quickly.
as a scientist, what principles guide you and what or who inspires you most?
I don't know what you mean by what principles guide me. I try to be honest, okay? I work hard, but
Yeah.
I don't work hard in order to work hard. I work hard because I'm fascinated with what I'm doing and I'm interested in finding out what happens. So I do think that people that go into science can expect that they have to work hard, and they shouldn't look at that as a punishment or anything like that, but as an opportunity. I mean, there's nothing like discovering something at 2:30 in the morning.
So what or who inspires you most?
I don't know if anyone inspires me anymore. I'm on the other side of that. I'm trying to inspire lots of young people. So I go around the country and around the world, you know, telling stories of discovery and you know, giving advice to students and things like that. And the number that actually, you know, write back, dear Professor Osheroff, thank you for the advice you gave me. I've just discovered something. That doesn't happen very often, but I hope that I'm giving good advice and that at some point someone will say thank you for, for what you did, but it hasn't happened so far.
So what role does your family play in your scientific success story?
Oh, well, first thing you have to understand is neither my wife, we don't have children. We never had children. I think we were both very passionate about our careers. She's a biochemist, and of course, I mean, I had just discovered superfluid helium-3, and so I think we have a very close marriage. We love each other, and I think we kind of make time to be together, but we never had children. And so when students ask me this question, I say, no, I think of you as my children, academic children, yes, not,
So you're, as you said, intellectual offspring. So
yeah, exactly, yeah.
Well, thank you so much, Professor Osheroff, for an absolutely inspiring conversation. We wish you all the best in your future endeavors and hopefully see you soon in Vietnam again.
Okay, well, I look forward to coming back.
Thank you.
Thank you very much.
And that's all for a special edition of Talk Vietnam today with Professor Osheroff, the 1996 Nobel